All right, here we go. Today we are reviewing for our test. Day 3 of reviewing for our test. Our test is on Wednesday. Remember, it's a Wednesday test, so that means you have substantially less time to do it. I would not say this is the world's longest test, but you want to make sure you're moving, and that means you know what you're doing. Okay? Today we are going to review, making sure we understand what's going on. On the first one here, you're finding the area under the curve from -2 to 3, so in between those two red lines. Let's start doing that. We can break this down into whatever shapes we want. I'm going to break that down into a rectangle. What's the area of that rectangle going to be? 8, but it's really going to be -8 because it's below. This guy right here, it is 1 across and 4 tall, but it's a triangle, so it's really going to be -2. You can break this guy down. This is going to be +2 because it's the same as the other one. Those two things basically cancel each other out. And then this guy right here would be 1, 2, 3 and a half. Everybody good with how I broke that up? You can do it however you want. That's what made most sense to me, so that's the way I did it. Okay. Once I've done that, I'm just finding it from -2 to 3. I'm adding them up. These are negative. Those are positive, so it's -10 plus 5.5, so -4.5. Questions on the first one? The second one, -2 to 3, g of x plus 1. Show me the fingers, point. Which direction does this +1 take your graph? It shifts me up 1. So if I took everything and moved it up 1, again, it is like finding this guy, which we already found, and then finding the integral from -2 to 3 of 1 dx. Show me with your fingers, what's your answer going to be if you shift that whole graph up 1? What are you going to add if I'm integrating from -2 to 3 and you're integrating 1? Oh my gosh, guys, wake up. 5, thank you. You add 5 because it's 3 across or 5 across and it's up 1. So you take -4.5 plus 1, or I'm sorry, plus 5 because it's a width of 5. You have a rectangle. Okay, if I were to graph that, it'd be up 1 and it would go from -2 to 1, 2, 3. That's what I'm adding to this graph. I'm adding a box of 5. So if I add a box of 5, my answer is going to be 1/2. My last one, I'm going from -2 to 3, g of x plus 1, point. Which direction is that +1 going to take your graph? It is shifting you to the left one. So if I'm shifting to the left one, think about what that means. My red lines don't change. I'm still going between -2 and 3, but I'm taking every point on this graph and I'm shifting it to the left one. So all of these shift over. This shifts over. This shifts over. This right here shifts over. So if I am finding the area between these values, what I'm really finding the area between is this line right here and this line right here. Because if I took those points, like this point right here, and shifted it left 1, it would match right there. If I took this point and shifted it left, it would match right there. So I don't care how you do it. You can think about what the shift of the graph is going to be, or you can just change your bounds. You're really just like taking your x and adding 1. It's going from -1 till 4 is what you really want to find the area of. Okay, so then I know from -1. So this box would be -4, -2, 2, 3.5, and then I have to find out what this area would be. This would be 2.5. So this whole guy is 6, 7, 8, -2, 2. Somebody agree with me? Wonderful. Finding area under the curve. Don't let it be that difficult. It's not that crazy. Just doing some geometry, counting boxes. It's something we have to do quite a bit of. Questions on bell work? Wonderful. Today, we're going to do some whiteboard reviews. You got a wide variety of problems today, but we're going to try to see what's going on. Evaluate that integral. So 4 plus x to the 7th all over the square root of x. You got some multiple choice there to help you. Take a second to do it. Hold up your answer once you get it. Go. If you're stuck, first thing we're going to do is rewrite it. So it's 4 plus x to the 7/2 all over x to the 1/2. I still don't like it. What else can I do? Split the fraction. 4 over x to the 1/2 plus x to the 7/2 over x to the 1/2. I still don't like it. Simplify it, then take the antiderivative. Keep going. Let's go. Let's do it. We rewrote it. We're going to simplify. So I could rewrite this as 4x to what power if it's on bottom? -1/2. This one, it's 7/2 over 1/2. Remember, when we're dividing things, we just subtract their exponents. So 7/2 minus 1/2 is 6/2, or in other words, 3. We're finding the antiderivative. So we add 1 to our exponent. We divide by our new exponent. If we're dividing by 1/2, it's like multiplying by 2 over 1. I get 8. Add 1 to my exponent. Divide by my new exponent. It's D. Questions on that one? I don't feel like this is the one to go to next, but we'll try it anyways. Find y equals f of x. So basically, you're trying to figure out f of x, but they're not giving you f of x. They're giving you f double prime, and then f prime at 0 is 3, and f of 0 is -1. What do we need to do with this f double prime in order to find f of x? Find the antiderivative. When you find an antiderivative, it's going to be plus c. That will tell you the first derivative, but that's not good enough. You got to figure out your c. Then do it again. Find the antiderivative from there. Go. Good. We're doing a little bit better on this one. We start off here. We want to find f prime. They told me f double prime. I'm trying to get to f. So first thing I do is find f prime of x. If I find the antiderivative x plus 2. If I find the antiderivative x plus 2, I add 1 to my exponent. Divide by my new exponent. Add my new exponent. Divide by my new exponent. That's my antiderivative. I didn't have bound, so it's plus c. Okay, so once we've got to that point, then we are figuring out what c is. They told me that f prime of 0 is 3 and 3. 0 and 3. So I plug it in. So it's 1/2 times 0 squared plus 2 times 0 plus c is all equal to 3. So I know what c is. It's 3. Found the antiderivative. 1/2 x squared plus 2x plus 3. All I did here was I took this 3 and plugged it in right there. Now that I've got that, I want to find f. So to find f, I'm going to do the antiderivative again. Add 1 to my exponent. Divide by my new exponent. So I'm dividing by 3. Add 1 to my exponent. Divide by my new exponent. Add 1 to my exponent to the first. Divide by my new exponent plus c. Last thing I do is plug in 0 and -1. 0, 0, 0. It's going to be equal to -1. That means my c is -1. It's A. Questions on that one? Just understanding what you got and what you're trying to get to. Be careful there. Make sure you can handle what's being asked. That was the first one was an indefinite integral. The last one was finding a particular solution. This is finding a definite integral. You got bounds on this point. On this one, find the antiderivative. Work from there. Go. We're finding an integral. So first thing we're going to do is find the antiderivative. So we're finding capital F of x. It was square root of x, which I hate. We could rewrite square root of x as x to the 1/2 power. So we add 1 to my exponent. Divide by my new exponent. So make sure you're flipping that. You get 2/3, not 3/2. Okay? Once you've done that, then you're evaluating that thing. You're starting at 0. You're going to 1. So if I plug in 1, it is 2/3. You can factor out that 2/3 if you want because it's a constant. And then I'm going to go 1 to the 3/2 minus 1 to the 0. I'm taking this and plugging it. I'm sorry. I'm plugging this in. I'm plugging this in. All I did was factor the 2/3 out because it was a constant. 1 to the 3/2 is 1. 0 to the 3/2 is 0. 1 times 2/3 is 2/3. Questions there? Let's try that one. It is a weird problem. Again, I know that these are weird. I know that you might not be super comfortable with them. You got to practice them. If you're still looking at these and you're like, I don't know what I'm doing, go to Khan Academy. Okay, I've posted a whole thing on Schwann Academy about it, and you can do 100 of them. Okay, right back to back to back, and it'll be pretty helpful to you, and you could be able to figure them out pretty quickly. I also posted our thing that we did on Tuesday in class. That's on there as well. That quiz is, so that would be helpful to you. Okay, but as I look at this thing, okay, the thing that stands out is the 4 on top. So what is that 4 on top telling me? That's the width. So they all should have a width of 4. All right, cool. I can't eliminate anything. The next thing I notice is this 2 hanging out in front. That is not where you plug in and lower bound. A lower bound is going to be plugged on the inside. So that 2 plus better be in my equation somewhere, but it's not x. So it's one of these 3. Okay, the other thing I notice is this 3 right here. This 3 is the lower bound. So if it's a lower bound, it's not going to have another 3 in it, and the lower bound is going to be 3. It's that guy. The lower bound is 3. The width is 4. You start off with this equation. It's 2 plus, and then underneath here, you're plugging in the lower bound plus the width. Okay, it's a weird problem. You just got to practice them. Questions there? Let's go to that one. Evaluate. I did pretty well here. We are finding the antiderivative. So first thing I'm going to do is find capital F of x. It's 5 sine x. So, William, what comes before sine x? Negative cosine x, because we're going Snapchat, negative Snapchat. We're at sine, we go backwards. Negative cosine x plus, I got a 2. Andrew, what's coming before cosine? It's sine. Cosine go backwards, it's sine. X, we could go plus c, but it's not plus c because I got bounds, 0 to 2 pi. Okay, then I plug in, so it's negative 5 cosine 2 pi plus 2 sine 2 pi. That's what I got when I plugged in the upper bound. Then I'm going to plug in the lower bound, so it's minus negative 5 cosine of 0 plus 2 sine of 0. Is that good? No, it's bad. Why is it bad? Parentheses, because you're subtracting all of that. I'm going to do it every time wrong so that you learn and don't do that. It's bad. Okay, cosine of 2 pi, so 2 pi is over here on your unit circle. Cosine is the x value is 1. Negative 5 times 1 is negative 5. Sine of 2 pi. 2 pi is right there. Sine is the y value. It's 0. So that's 0. Minus negative 5 times cosine of 0 we just said was 1. Because the same spot. 2 sine of 0 is 0. So it is negative 5 minus negative 5. They get you 0. Make sense of what we did there? Wonderful. Look at that one. Think about it. See what you can do. Go. At first glance, you look at this one. You're trying to figure out what is going to get you the shaded region. F of x is this guy right here. Well, from where to where do we shade on this graph? Negative 5 to 5. And so your first instinct is going to be to pick E because it shades from negative 5 to 5. But is that going to tell me the area under the curve? Why not? Because there's a 2 in front. You're going to have too much. You have too much because you're multiplying by 2. Okay? So instead, this looks like a symmetrical graph. So instead of going all the way across, let's integrate from 0 to 5. So in other words, find this area. If I find that area and then double it, it will tell me the whole area under the curve. Kind of weird, but it's just understanding that, hey, we can double stuff and it'd be perfectly fine. Questions on that one? Let's do this one. Good at this one. What are we trying to do with this integral? What are we doing with this integral? Finding the derivative. If you find the derivative of an integral, this is called the fundamental theorem of calculus. You can do it the long way. If you want to find the antiderivative and then plug in the upper bound and the lower bound and then get an equation and then take the derivative of it, you can. Or you take x. Where does it have to be? It has to be on top. If it's on top, great. We plug it in. So now it's 4 times 3x to the 1/2 power. And then you've got to multiply by the derivative of whatever you plugged in. So what do I need to multiply by? 3. 4 times 3 is 12. Times 3x to the 1/2 power. That's my answer. Questions there? Actually, that's not the answer. The 1/2 is on the outside. All right, let's keep going. Let's do this one together real fast because we haven't done it in a minute. What is this shape going to be on my graph? It is not a square root. It is a... Oh, we did this before break. It is a semicircle. Remember when we did that? It's a semicircle. It's the way you can tell that it's a square root and there's a square underneath. Okay, it's a semicircle. That is something you need this semester. We're going to do it quite a bit. What do you think the radius of that semicircle is going to be? 3, because we're taking the square root of that. So it is 3. And so this is the shape that's being depicted. You're finding the area from -3 to 3. Give me an answer, A, B, C, D, or E. You got to be able to recognize, oh yeah, that's a semicircle. I know it's tough, but you'll do it a lot. Second semester. Good. It's pi r squared. It's pi times r squared. My radius is 3, but I got to cut that in half because it is a semicircle. It is 9 pi over 2. Try this one real quick. This is the one you did on your quizzes the other day that everyone did really bad on. What do you notice about your bounds? Do it. Go. Where are we starting to find the area under the curve? 0. You're starting at 0 and you're working to -4. Since I'm working backwards, I don't like that. I'm going to flip them. If I flip them, what do I got to do with my integral? Negative. And so it is going to be a negative area under the curve, and we know that that number is -6. So -6 is +6. Let's get one more. I lied. Let's try to get 2 more. I like this one too. See what you can do with that. Good. We're given this. We have to figure out this. What is different about this and that? It's flipped. So if I flip the bounds and made it from 3 to 2, f of x, what would it be equal to? -5/2, because we flipped it. Okay. The other thing we notice is I got a 12 right there. So what do you think I got to do with that 12? Multiply it, because we can just pull a number out in front. If I just pulled a 12 out in front, it's the same thing as integrating underneath. So if I multiply that by 12, the 2 and the 12 could reduce to get you 1/6. -5 times 6 is -30. Good there. One more. We haven't really done any of this yet today, but let's see it. Gasoline is pumped into a tanker truck. The rate that gas is being pumped in is given in this table. Use a left Riemann sum. Oh, no, I lied. Let's use a right. Oh, that's so much worse. With 4 sub-intervals. Now let's go 3. To figure out the total gasoline pumped in the car over that time. So let's go integral from 4 to 16. Do it. Intervals. So I should have 4 numbers. I do. Boom, boom, boom. My first span is 4. Which number am I using if I'm doing right Riemann sum? 40. 4 times 40 plus. Then I'm going to use 4 times 50 plus 4 times 45. We can work through all of that. The one thing I noticed that they all have a 4 in them. And then you can go 40 plus 50 plus 45. Do the different math. We got 540. What does that represent? That 540 represents the change in gallons. That's what that represents. It is the change in gallons. What if I then said, what if you did 1/16 minus 4? So you took this number and you divided by 12. Now, talk with your neighbor. What does that represent with units? Talk to each other. When you put this guy in front, it changes a whole lot. It is no longer the change. What does it do when you divide by the width? What is that going to tell you now? This is the average what? The average of whatever they gave me. So it is the average gallons per minute over that time interval. Okay, it's a big difference throwing that little number in front. It changes it from being the change in gallons to the average gallons per minute. Okay, so it changes your units quite a bit because you're dividing by minutes again. Okay, this without that number, it's the gallons. When you put minutes, divide by minutes, it's gallons per minute again. Okay, pay attention to that. You can kind of